Good day, everyone. Our lesson for today is all about algebraic properties of matrix operations, specifically properties of matrix addition, properties of matrix multiplication, properties of scalar multiplication, and properties of transposition. To start with, in this section, we consider the algebraic properties of the matrix operation just defined. Many of these properties are similar to the familiar properties that hold for real numbers. However, there will be striking differences between the set of real numbers and the set of matrices in their algebraic behavior under certain operations. For example, under multiplication, the proof of most of the properties will be left as exercises. For this lesson, the objectives are as follow. Number 1, apply theorems in verifying the given matrices. 2, solve problems involving the properties of matrix operations using its properties. And 3, prove theorems involving matrix operations using previous theorems and properties. The objects of study in linear algebra are linear operators. We have seen the linear operators can be represented as matrices through choices of ordered bases, and that matrices provide a means of efficient computation. We now begin an in-depth study of the matrices. Theorem 4.1 Properties of Matrix Addition. Let A, B, and C be M by N matrices. Hence, we have A plus B equals BA as the first property of matrix addition. Next is A plus B plus C equals quantity A plus B plus C, which is I think that is associative property. And then for letter C, there is a unique M by N matrix 0 such that A plus 0 is equal to A, which is an identity property. For any M by N matrix A, the matrix 0 is called the M by N 0 matrix. For each M by N matrix A, there is a unique M by N matrix D such that A plus D equals 0. We shall write D as negative A. So, in number 2, can be written as A plus quantity negative A equals 0. Parang ano lang siya, 1 plus negative 1. Parang ganun siya, which is equal to 0. The matrix negative A is called the negative of A. We also note that negative A is negative 1 of A. Okay, so these are the different properties of matrix addition. Example, if A or matrix A is equal to the square bracket of a 2 by 2 matrix 4, negative 1, 2, and 3, then square bracket of 4 or the matrix A, which is 4, negative 1, 2, and 3 plus 0, 0, 0, 0, which is the identity property, letter C, equals 4 plus 0, negative 1 plus 0, 2 plus 0, 3 plus 0 is equal to 4, negative 1, 2, and 3. The 2 by 0 matrix is 0 equals 0, 0, 0, 0, 0, 0. Okay, so in this portion, itong portion na to, okay, using the identity property, kapag pinag-add mo daw ang isang matrix sa isang matrices or sa isang matrix na 0 lahat ng kanyang values, therefore singular lang ang makukuha mo or same lang ng mga numbers na nandoon. Okay, example 4.2. If A or the matrix A is equal to 1, 3, negative 2, negative 2, 4, and 3, then negative A, which is the negation of A, is equal to negative 1, negative 3, 2, 2, negative 4, and negative 1, that when you add them, the answer is equal to 0. Next, properties of matrix multiplication. If A, B, and C are matrices of an appropriate sizes, then A quantity B C equals quantity AB times C, which is actually a associative multiplication. If A, B, and C are matrices of appropriate sizes, then A quantity A plus B times C is equal to distributive property A times C plus B times C. Okay? And now, if A, B, and C are matrices of the appropriate sizes, then C quantity A plus B is equal to CA plus CB. Okay? May be similar to letter C may be similar to letter B, but I think in this portion there might be a possibility that the answer for the matrices is different, just like in the past discussion that AB matrices is not equal to BA. Okay, so let's see now how these things will go on. Okay, so let's have an example. We have two matrices, no, three matrices, I mean. So we have A, B, and C. For A, we have the square bracket of 5, 2, 3, 2, negative 3, and 4. For matrix B, we have 2, negative 1, 1, 0, 0, 2, 2, 2, 3, 0, negative 1, and 3. And for letter C, we have matrix 1, 0, 2, 2, negative 3, 0, 0, 0, 3, 2, 1, 0. Now then, A quantity BC is equal to what? Okay, so since if you still remember the what we call PEMDAS, okay, so una yung parenthesis, BC muna. So we will multiply B and C. Okay, so don't forget the row times the column. Okay, so that's and then as you go on with that process, okay, the row times column process of multiplying B times C matrices, I believe you already know this because I already discussed this in the previous discussion, huh? So once you multiply B and C, you will get 0, 3, 7, 8, negative 4, 6, 9, 3, 3 as your product. After that, the product of BC will be multiplied from A. So 5, 2, 3, 2, negative 3, 4 will be multiplied to 0, 3, 7, 8, negative 4, 8, 6, 9, 3, 3. And the answer is 43, 16, 56, 12, 30, and 8. So that's the final answer for A quantity BC. Now how about quantity AB times C? So for this one, we will multiply first A to B. So that's A times B. And you will get 19, negative 1, 6, 13, 16, negative 8, negative 8, and 6. And we will multiply to the product of A, B to C, which is 1, 0, 2, 3, I'm sorry, 2, negative 3, 0, 2, 0, 0, 3, 2, 1, 0, and you will get the same. Therefore, as a conclusion, based on the properties that A quantity BC is equal to quantity AB times C. It is proven from this example. Okay, that A quantity BC is equal to quantity AB times C. Okay, based on the property number letter A of the matrix multiplication. Another example. So we have here A quantity 2, 2, 3, 3, negative 1, 2, and then B equals 0, 0, 1, 2, 3, negative 1, and C is 1, 0, 2, 2, 3, negative 1. Now, for this one, we have A plus B quantity C. I'm sorry, quantity A plus B times C, and we have a distributive of this one, which is A times C plus B times C. Now, let's see if we will get the same. So as you can see now, actually, we can already see in the screen that they are the same. But how about the process? So in this portion, we will add A and B first. So we will add A and B. So 2 plus 0, 2 plus 0, 3 plus 1, 3 plus 2, negative 3 plus 3, negative 1 plus 3, I mean 2 plus negative 1. And you will get 2, 2, 4. Is this correct? I don't think so. Okay. So 5, 2, and 1. Then after that, multiply to letter C. So C is this one, right? And using row times column, you will get an answer of 18, 0, 12, and 3 as your final answer for the product of the A plus B, and C. How about this one? So in here, in this portion, AC means to say A times C plus B times C. The product are 15, 1, 7, negative 4, 3, negative 1, 5, and 7. Then we will add them. We will get the similar. So therefore, in this property of letter B, it is concluded that they are the same as based from example 4.4. Now let's proceed to the properties of scalar multiplication. So if R and S are real numbers and A and B are matrices of the appropriate sizes, then R is the number that will be multiplied to the matrix, no? That's why they call it scalar multiplication. R quantity SA is equal to the quantity of RSA. Then B, quantity R plus S times A is equal to, by distributive property, we have R times A plus S times A. R quantity A plus B is equal to R times A plus R times B. And finally, R quantity RB is equal to or similar to R quantity AB or quantity RA times B. Okay, these are the properties. So let's see by examples how these properties will go on. So let example number 4.5, we have two matrices. A is equal to quantity 4, 2, 3, 2, negative 3, and 4, and B is equal to to matrix or square bracket 3, negative 2, 1, 2, 0, negative 1, 0, 1, and 2. Then the product of two quantity 3A, which is that is the R, quantity SA, is equal to 2 3A. So we need to multiply first 3 times A. So 3 times 4, 3 times 2, 3 times 3, 3 times 2, 3 times negative 3, and 3 times 4, you will get this product. And then there is another number outside the quantity, which is 2. Therefore, we need to multiply it or distribute the 2 to the numbers in the square bracket. So we have 2 times 12, 2 times 6, 2 times 9, 2 times 6, 2 times negative 9, and 2 times 12. And then you will get this answer. Also, it is also this 2 quantity 3A can be represented by 2 times 3, which is 6. So we have 6A. So we can do 6A. And we will have an answer similar to this one without any long process or doing a long process. Another, we have A quantity 2B, which means A quantity RB. So in this portion, we need to process the number under the quantity or parenthesis. So we have 2 times B, and you will get 2 times B. Where's that? Okay, this one, 6, negative 4, and I think there's something wrong with this. So wala siyang equal sign. This should be deleted, no? This is excluded. This should be multiplication sign, I think. Okay, this one. This should be a multiplication sign because we are going to multiply the product of 2B and A, which is A. This is 2B. Okay, so we have this one. So by doing a row times column, so we will have 32, negative 10, 16, 0, 0, and 26 as our answer. Similar to A quantity 2B, it is also, or we can also represent that into 2 quantity AB. Now, the last property will be the properties of transpose or transposition. So we have A is equal to, or properties of number 1, we have quantity A raised to T is equal to A. Parang tabla siya, no? Parang kinansel lang natin yung dalawang letter T. So for letter B, we have quantity A plus B raised to T is equal to, just like distributive, so we will distribute the exponent, which is T. So A raised to T plus B raised to T. For letter C, we have quantity AB raised to T, which is also equal to B raised to T and A raised to T. So as you can see, we exchange A and B here. So next one, we have R A raised to T, which is also similar to R A raised to T. Okay, so to prove these properties of transposition, let's have the following examples. So example 4.6, we have A equals quantity 1, 2, 3, negative 2, 0, 1. And for B, we have 3, negative 1, 2, 3, 2, and negative 1. For A raised to T, or the transposition of A, so ang susulat natin is yung row gagawin natin column. So we have 1, 2, 3, 1, 2, 3, negative 2, 0, 1, negative 2, 0, 1. And for the B raised to T, we have 3, negative 2, negative 1, 2, dito yan, 3, 2, and negative 1. For A plus B, add natin si A plus B. And then, yung nila, transposition, itong sum nila, ito transpose lang natin, which is 4, 1, 5, 1, 2, 0. On the other hand, we have A raised to T plus B raised to T. So, 'di ba sabi doon sa properties, it is similar to A plus B, quantity A plus B raised to T. So, kung ano yung answer natin dito, similar lang yung answer natin dito. Because, based on the property, similar lang sila. They are just equal. Alright? Another, we have A, quantity A, 1, 2, 1, 3, 2, okay? Then, for B, we have this 0, 2, 3, 1, 2, negative 1. For A, B, we have 12, 5, 7, negative 3 as the product of A and B matrices. For the transposition, we have 12, 5 at the end, 12, 5, 7, negative 3, 7, negative 3. On the other hand, we have A raised to T, which is 1, 3, 2, negative 1, 3. Saan ko ito nakuha? Dito yan, no? Sa letter A. So, we transpose letter A. And for the B, ito yan, gagawin natin siyang ganito. And then, we will multiply A raised to T and B raised to T. This one. So, 1 times 0, parang ganun siya. 2 times 1. Okay? If you get my point, no? Parang, tama ba ako? Yeah. Row times column. Okay? So, in the end, we will get an answer of 12, 7, 5, and negative 3 is equal to the quantity of AB raised to T. We also know that two other peculiarities of matrix multiplication. If A and B are real numbers, then AB is equal to 0 can hold only if A or B is 0. However, this is not true for matrices. Okay. Maybe you are wondering. Okay, I'm sorry. There's something wrong with what I've answered dito sa portion na to. We will start with B muna pala. So we have 0 times 1, tama ba? 2 times 3, 3 times 1, and you will get 12 pag pinag-add mo lahat. Next is 0 times 2, 2 times negative 1, 3 times 2, and 7 yung makukuha mo pag pinag-add mo lahat. Kasi nga pala, B muna bago yung A. Okay, balikan natin. That is B. So, AB raised to T is equal to B raised to T, A raised to T. Okay, I'm sorry. Nakaligtaan ko kanina. Okay? Now, another example, we have A equals quantity 1, 2, 2, 4, and B 4, negative 3, 6, negative 2, and then 3. Then neither A nor B is the zero matrix, but AB is 0, 0, 0, 0. If you will try to solve it, let's see, 1 times 4 is 4, 2 times negative 2 is negative 4, so that's 0. And then 2 1 times negative 6 and 2 times 3 is also 0. So, yung ending 0, 0, 0, 0 tayo. If A and B and C are real numbers for which AB is equal to AC and A is not equal to 0, it follows that B is equal to C. That is, we can cancel out the non-zero factor of A. However, the cancellation law does not hold for matrices, as the following examples shows. So we have A equals quantity 1, 2, 2, 4. B is equal to quantity 2, 1, 3, 2. And C is equal to quantity, square bracket, kanina pa ako nagko-quantity, I'm sorry, negative 2, 7, 5, negative 1. Then AB is equal to AC is equal to 8, 6, 8, 5, to 16, and 10. So AB, if you multiply A and B, you will get 8, 5, 16, and 10. If you multiply A and C, you will also get 8, 5, 16, and 10. But B is not equal to C. We summarize some of the differences between matrix multiplication and the multiplication of real number as follows. For matrices A, B, and C of the property sizes, AB need not equal to BA. That's actually a proposition that was given in our previous video, that AB is not equal to BA. AB may be the zero matrix with A is not equal to 0 and B is not equal to 0. And AB may equal A to AC with B is not equal to C. Okay? Obviously, B is not equal to C, but A is equal to A. Right? A is equal to A, but B is not equal to C. So that's all about for algebraic properties of matrix operations. I hope you learned something for today's lesson. Good day.